So guys, as I mentioned in my last video, I actually work for a small consulting company, called Covantage. Look us up on LinkedIn or the internet if you're really interested. And as part of our marketing strategy for the year, we wanted to provide some predictions on LinkedIn on what we think the market's going to look like for the year. So I wrote my predictions out and I sent them off to my mate Ben. Ben actually ran them through ChatGPT, and my 2 paragraphs of predictions came back with about 6 paragraphs of recommendations for changing it. I think if I put all the recommendations in, my 2 paragraphs would probably go out to about 6 or 7 pages. So that got me thinking about AI and how we use AI in business and how we can actually make the most of it. So that's what I want to focus on in this video. How do we actually make the most of AI in a finance setting? So the first myth I want to dispel is that general artificial intelligence actually exists. So AI as it exists in movies or as it exists in a purely computer science definition hasn't been invented yet. We don't have machines that can comprehend, learn, and apply like we can as a human. What we do have, though, is actually a pretty powerful tool for business, and that's what we want to explore in this video. So guys, to understand how AI works, I think it's really important to understand how computers actually work. And I know this is an oversimplification, but I think it'll help you. Computers work really well when we give the computer a table of data. In this case, it's a table of pets with a whole bunch of information around them. Now, we can introduce a condition to this table of data to actually extract more data. So for example, if the animal is a dog, then give the dog a treat. So we can then apply this condition to the table of data. The computer will look at all the animal types there. And if it says, hey, animal type equals dog, then the computer will say, hey, yep, I'll give that dog a treat. So this worked really well until someone sort of said, well, what happens if we don't actually have a category that says dog, yes, no? How do we determine if something's a dog? And the computer scientists went away and they thought about this and they said, well, actually, maybe we can still make that determination. So what they did is they actually expanded out the criteria. They said, let's go and collect more information on all these different things, and we'll collect information on what a typical dog is, and then we'll compare the record to what a typical dog is. And if it gets a score of, say, 7 or greater out of 9, then we'll consider it a dog and we'll give it a treat. And this actually works quite well. It's a kind of cool way of actually analyzing things. But you might notice one problem down the bottom there, and that's poor Rambo, who was a dog, doesn't actually get a good enough score to be considered a dog, whereas Fluffy, who's a cat, is almost considered a dog. So it wasn't a perfect system. So by collecting far more information about an animal, we were actually in a better position to make a determination on what animal was a dog. So for example, if we started collecting a whole bunch of physical characteristics around a dog, we might collect height, length of leg, distance between legs, paw size, tail size, back size, neck size, the length of its snout, its muzzle, everything like that, we'd get a better picture of what a dog was. And then we could actually add additional dogs in there that had different physical characteristics. What's more, we were able to tell the computer that we are 100% certain that this record is of a dog. So the computer was able then to build up a physical picture of what a dog would be. Now, there wouldn't be any particular animal that meets all the average characteristics of a dog, but what we could have is a confidence interval. So that confidence interval would cover a whole range of things, but be able to tell the computer what is most likely to be a dog. Now, one of the problems with this approach is we're kind of only comparing individual physical characteristics to other individual physical characteristics. So for example, snout length, we will compare the snout length of the animal compared to the snout length of all the dogs that we know. And if it fell within that confidence interval, we would say, yes, this is the snout length of a dog. Same with legs, same with paws, same with tail. So far, what we've covered off here, I would kind of consider traditional computer stuff. We're getting the computer to make a yes-no decision based on a set of criteria. And what the computer scientists did next was the machine learning bit. And this is the cool bit, and this is where it really starts to advance. What they said is, okay, we've collected maybe 400 pieces of information about an animal, and we know that dogs have certain characteristics. So what they told the computer to do is go away and look at each of those fields in isolation and in combination. So they started looking at things like ratios. So does a dog have a fixed ratio, maybe leg length to back length, or snout length to neck length? And the computer actually went away and did all these calculations itself and came back and said, well, hey, guess what? Based on the 300 or 400 bits of information you've told me about a dog, I've actually learned some more information. I might have learned that, say, for example, a dog that is under 5 kilos has a snappy, annoying temperament, like my dog, for example, and we probably kind of all know that. But it also might find out other things that we didn't realize, that a dog that, say, has a certain paw length is more likely to have a certain ear length or a certain neck length. So with this new technology, I do like to think of it as machine learning rather than AI, simply because I think it's a better representation of what the machine actually does. Just think of it this way. If we showed a machine one picture of a dog and then showed the machine a second picture, it would probably not recognize it even if it was a dog, because there's just so many different variations of dog out there. But the more information we put in, the more it learns what a dog is. Secondly, it has the ability to make those distinctions itself and look at different ratios and pick up different characteristics about dogs that we may not have programmed in there. So I think it's better to think of this as machine learning rather than artificial intelligence. So two main characteristics about this new software that are really important to consider now is that the more information we actually fed in about each individual animal, the better it was going to work. Secondly, the more records we filled in, the better it was going to work. If you can imagine all the different types of dogs out there, shapes, sizes, temperaments, everything like that, the more information we had and said, yes, this is a dog, this is a dog, this is a dog, the better the computer was going to be at recognizing what a dog was. And that's where the third and final element of AI really comes in as we know it today, and that's the technology advancement. So we had software that was very hungry for data, and we needed to actually continue developing our hardware so it could actually store, retrieve, and process more data. So look, there's two characteristics about this technology that I think are really important to explore, especially when we start to think about how we're going to use this in a business context. The first of all is it is a data-hungry system. It wants millions and millions of records, and the more records you feed into it, the better it's going to perform. Secondly, we have just spent a whole bunch of time teaching our system how to recognize what a dog is. If we want to recognize what a cat is, we kind of have to go right back to the beginning and start learning again and feed in another 1 million or 2 million records worth of cat information so it can make a distinction between a dog and a cat. Same if we would start looking at horses or other animals. So once we've used the technology for one situation, it doesn't mean that we can easily adopt it for another situation. So when we start looking at practical applications for this machine learning technology, there's a couple that really come to mind. One of the first uses for machine learning technology that was widely available for business was document reading or optical character recognition. And this would simply be where the computer would actually scan the document, turn that whole document into text, okay, and then it would actually apply the machine learning to the top of that text. And it learned that the number next to the words invoice number was most likely to be the invoice number. But it also learned that things like invoice hash can be an abbreviation for invoice number, and occasionally maybe the number below the word invoice number is the invoice number. It learned those variations and it was able to apply those. The next main use that came out around machine learning was doing things like audit. So we were able to take an invoice or an expense and audit that and pick up things like the company number and get the machine to go and look at that company and say, hey, does this company actually exist anywhere apart from on this invoice? And if the answer is no, we'd flag it up and say, hey, there's potentially a bogus company here. The third generation, I think, of AI or machine learning has really been starting to automate some of those common processes that you have within your business. So maybe bringing somebody on, hiring somebody could be a common process. Accounts payable could be a common process. Even accounts receivable and maybe even payroll can be some sort of common processes. And when I say common processes, what I'm saying is those processes that are actually widely similar to what most other companies do out there. And the reason why those offerings were available is because the data scientists and the software companies were able to actually teach the machine how these processes generally work. And the machine was going to be able to learn that, and then we can take that learning and apply it to your business. And as long as you have a fairly common process, that actual system will work. So one of the things you might notice about AI offerings is they're pretty much uniquely cloud-based. You can't get an AI offering and load it up onto your own laptop or your own server. And the reason is because all these cloud-based AI learnings require the millions and millions of rows of data to actually be effective. So when we look at where AI will work and won't work, you need to be able to think about that in terms of how much data can I feed into this system. So where it won't work is when you have a unique process or a unique set of requirements that are really only your business, because you're simply not going to be able to gather the millions of records that it needs to work effectively. So applying machine learning to your business is really about looking at your business and saying, where am I going to be able to get those millions of records and apply it effectively? So accounts payable has been an area that's kind of like common amongst a lot of businesses. Most businesses around the world do the same sort of functions with accounts payable. So it's possible for us to take machine learning, gather information from hundreds of businesses out there and apply it to your business, and it's going to be a fairly good fit. Also, when you look at processes, a lot of processes are actually the same across businesses. You know, the way people raise purchase orders or hire staff is actually not that dissimilar when you look at business to business. So that's an area we can look at machine learning. We can also look at machine learning around things like auditing expenses and invoices to check that people aren't trying to sneak things through or pay things in the way that they shouldn't be paying them. But the last area we can look at is communications. And I want to be really careful with this one. Communications where you're looking at a volume communication is something where we can look at machine learning and say that can help us. So if someone's just emailing us and saying, hey, when are you going to pay this invoice? When are you going to pay my claim? We can have a machine learning reply to that. That's just a kind of a form standard reply. The one place I wouldn't have any machine learning is when you have a unique process or when you want that personal touch. So guys, to finish up, I suppose it's best to go back to the start and look at my ChatGPT comment. Yeah, ChatGPT will give you some suggestions. They might be good suggestions, they might be bad suggestions, but the suggestions it's going to give you are going to be based on millions and millions of articles that it has access to, and the learning is based on those articles. Now, in some cases, that's going to be useful, but in other cases, you're going to find that it's probably not, and it could become rather generic and kind of not personal at all. But that's how machine learning works. Anyway, guys, I'm Andrew Chapman. If you like my content, smash the subscribe key. If you've got any questions or comments, put them in the comments down below. And of course, if you need help looking at AI and machine learning and how you can use that in your business, this is what I do for a living. So reach out.